All right, so today let's see what we're doing with. We got a problem statement. Given an array with positive numbers and a target number, so here's our array of positive numbers, here's our target of 30. Find all of its contiguous subarrays whose product, that's multiplication, is less than the target number. So 2 times nothing is 2, well, not times nothing, but 5 is less than 30. 2 times 5 is 10, less than 30. 3 less than 30. 15 less than 30. 10 less than 30. So 1, 2, 3, 4, 5, 6. We want 6 subarrays that give us 30. So we're using the 2-pointer pattern. This is in the 2-pointer section of Grokking the Coding Interview. Let's see what we can get up to. I've already pasted in the sort of default pattern. So first we're going to sort our array. We take in the array and the target. We're going to sort our array in ascending order. Then let k equal to the length of the array, and then loop through each index of the array using this for loop and the variable I representing the index. Now, in previous examples, previous 2-pointer questions, we had a left and a right pointer as well as this for loop. And then we did a while loop for the left and the right inside here. And the reason we did that is because we would start here, set I is equal to 2, and then this would be our left pointer at 5, and this would be our right pointer at 10. And we would either then move the right pointer or the left pointer to the right, or the right pointer to the left, and we would have 3 values, right? Because we had like 3 pointers basically. But on this problem, I don't know if we're not doing triplets, so I don't think we need 3 pointers per se. What we do need is to store all of the results into the results array. So let's just see. We'll just say P1 for pointer. Maybe not the best name, but I plus 1. So I0, P1. We'll just say P is equal to I plus 1. So this is I, this is P. Now, what do we want to do? If the product is less, so while, let's think about this. Okay. Let's go see what slice does. Slice, a new array object, returns the selected elements. Okay. So what we want to do is array.slice, and we want to start slicing at I, so start slicing at 0. And this is saying 3 orange lemon. That, boom, let's try 0, 0, 3, banana, orange, lemon. So 0, 1, 2, or 1, 2, 3. No, this is non-inclusive. So 0, 1, 2, 3, but we don't go to 3, we only do 2. So if we array.slice I, and then we do P this, so K minus 2. We want to stop when we're 2 less, so I and P. So let's just console .log array slice I P real quick. So we get 2 and 3, and then 3 and 5. So 2 and 3. That doesn't seem right. And then 3 and 5. What the heck is going on here? Oh, it sorts. Oh, okay. That's why I'm so confused looking at the unsorted array. Let's get this sorted one in. 2, 3, 5, 10. So we get 2 and 3. And that's good. And we get 2 and 5. And we only need -1, it looks like. So 2, 3, 3, 5, 5, 10. So array.slice gives us a new array. And we want to reduce that array. So we're going to grow an array. Right, we're going to grow the array from left to right. We're going to do reduce, blah, blah, blah. This is a sum function. And I think I need 0 in there. This is our default index or default value or whatever. Okay. So while our thing is still, while the sum is less than the target, what are we going to do? We're going to say we want a result. Well, let's do this maybe actually. If our sum is greater than or equal to the target, then what we should do is add everything except the last element. Because if we go 2 times 5 is 10, times 3 is 30, then we're going to hit this. So 30, we don't want it. So we don't want the 3. But we do want 2, we do want 5, and we do want 2 times 5, as you can see here. So then we'll we'd want every possible permutation of what we currently have, which is a bit complicated to type out, and there might be a more elegant way to just catch those two things. We want every permutation from I to p minus 1, right? Because if we slice to get p, and now, yes, we want p minus 1. So we want every possible permutation of okay, we can add the singles here. Okay. I got it, actually. So what we want to do, if array I is less than target, then we'll add it to the result array. If the sum of I to p, so this is a single number, this is at least 2 numbers. So if the sum is less than this, then result dot push array dot slice I to p, and we'll do a while, and then we'll do p++. And then let's see what we get back. This freezes. Why does it freeze? Well, let's console log it. Two, 3, 5, 10. So we don't want this. What we want is while P is less than K, and perhaps less than or equal to K, then so this is our array here. Why is that so? 2, 2, 3, 2, 3, 5, 2, 3, 5, 10, 3, 3, 5, 3, 5. Oh, I'm doing a sum instead of a friggin' multiply. So this must not be reducing the way I think it does. To Google. Total number. Reduce my func. Numbers is 175, 50, 25. So that should be 100, yeah. Maybe this 0 is screwing me up. A, B, A times B. Well, it's less than target. Push this, and then P++. If it's not, well, maybe we just want P++ outside of here anyway. Wow, okay, what do we have now? We have 2, we have 2, 3. Oh, but they have to be contiguous. What if I just break out here? Boom! Oh, okay, nothing. Oh, I can't sort it. So let's stop push. Two, 2, 5, 5. 5, 3. And I need 3 and 10. Why don't I have 3 and 10? I should. Hey, there it is. Two, 2, 5, 5, 5, 3, 3, 10. 2, 5, 2, 5, 5, 3, 10. And then what about this one? This one, 8, 8, 2, 2, 2, 6, 6, 6, 5, 5. 8, 2, 8, 2, 6, 2, 6, 5, 6, 5. So, whew, we did it. There it is. Now let's see what they did. So over here, find subarrays. They got a results. Yes, they have a product and left. So I did have left. I did have one pointer. I did not save a product array. So for right, blah, blah, blah. So, okay, they have a right value too, which is my I value. And they say, well, product times array times right, or array right. So product starts at 1. Then we add our first value. And then while the product is greater or equal to the target and left is less than the length, which is k. So that's what I have. Well, p is less than k, but they have a product is greater than equal to target. Oh, interesting. Since the product of all numbers from left to right is less than the target, therefore all subarrays from left to right will have a product less. To avoid duplicates, we'll start with a subarray and then extend it. Oh, so they do what I thought. They do find like a subarray and then slowly push all the elements. I made it more complicated. I didn't need all permutations. I just needed to do, 2, 5. Wait, do I? New deck. Unshift. I don't know what a deck is. That seems a little bullshit, but whatever. I mean, so, okay. What I'm left with now is a sense of confusion. I'm not exactly sure if I solved this properly because I did use 2 pointers to the best of my knowledge right now. But I am slicing this array and iterating over it constantly, looping through it constantly to find the target value, whereas this one does one multiplication at a time. I do every multiplication. I do the entire array every time. He divides off the old one. So let's think about this algorithm then. Can I make this bigger? Can we zoom in? Okay. Let's see then. So, right, product times equals array dot right. So, let's 2, 5, 3, 10. Okay. So we start off product equals array dot right. So product starts at 1. So product equals 1, but then it's gonna get multiplied by 2, right? 1 times 2 times 2. So it's 2. Then while product is greater than target and left greater or equal to, product is 2, which is not greater than our target of 30, right? So this does not run. Instead, what we do is this. So we push the 2, 5, 3, 10. So we'll push 2, I guess. to this and then go back up. So back to the top, right is now +1, so now right is 5. So our new product is 10. And now we're not over 30, so we skip this. And now I equals right. I is greater than left minus 1. So left is 0. So we have a 2. Unshift adds something to the end. Unshift adds one or more elements to the beginning of the array. Okay, so add something to the beginning of the array, which is, we already added a 2. We start at right. Right is 5, so we add a 5 first, so that's what we get. We added the 2 last loop, now we have a 5 this loop, and now 2, 5. Because we're going backwards through the loop, right? So we're going 5, we added the 2, we added the 5, and then we add 5, 2. Or 2, 5, right? We're extending what we're printing backwards. So now we get the 2, 5 in there. Now, so then we loop back up, and we get to the 3. The 3, oh no, we multiply by 3. So product is 30. So now something happens. Left is less than array length, which is important. So product divide equals array length. So divide equals 2, 15, and left goes to 5. So is product still less than this? No. So what do? First we add a 3 to the thing. That's why this 3 is here. And then we go backwards to the 5. So then we have 5 and 3. That makes sense. Then we go back up and product multiply is 10. So we have 150. So now we divide by the left value, which was, I should have been writing the left and the right value down, but left was 2. Then we moved it to 5. So we divide by 5. 150 divided by 5, 30. Okay. So we're still too high. So now we divide by 3 to get 10. So now our left value is 0, 1, 2. Right? Left value has an index of 2, and right is 10. So we have 3 and 10. Divide by 5. Oh, divide by 5 to move over, and divide by 3 to move over. So our left value is 10. Okay. And then, since we are greater, or we're less than 30, well, right is 0, 1, 2, 3, and left is 3 minus 1, which is 2. So I starts at here. Yeah, and then we're done. Okay. That was, I think, a more elegant solution than what I did. So let's see if I remember what just happened. Basically, up here, product equals 1. So we're going to work with a product instead of recalculating the array every time. Now, what we need to do here is, let's rewrite it using their variable names. Right 0, right is left than k, right plus plus. So if product is greater than target and product is less than target. So what do? First things first, product multiply equals our current array value. Then we say if product is greater or equal to target, and the left is less than K. Yeah, so we don't want to do what we're doing if left is K. And what are we doing? We're moving left over. So product divide equals array left and left plus plus. Simple enough. Then if product is less than target, what we do is they were using a deck. What the hell, man? Can I just use a friggin' array? Well, what's a deck? Deck is an ordered collection of values with fast random access, push, pop, shift, unshift. So it's like a random access array. Okay. Why is this? Oh. Okay, so let's make a new deck and then say for let's do this. Loop backwards through it. And then what do we want to do? We want to say result dot unshift array n. So we work backwards, right? So we've added the 2, then we'll add the 5 and then the 5 too. There was something else in this array though. Let's see. I see. The temp list. Yeah, the temp gets unshifted because we want to build upon it each time. So first the temp gets the 5 in it, then we shift the 2 to the beginning. So then did we unshift? Really? 5, 2? Yeah. Yeah, okay. And we got an error. Cannot find collections deck. Okay, where did you get this from? Okay, I can't use require, I think, because I'm not using Webpack. What if I just use this stupid thing? Left is not defined. This has to be negative. And that doesn't run. That's got to be greater or equal to left. What do we have here? 2, 2, 5, 2, 5, 5, 3, 5, 3, 3, 10. This is not correct. So were those two things equivalent? And no JS. What did I miss? Result, product, left. Do I not need to use let? Well, that's news to me. Oh, this is wow. Okay. There it is. Okay. Well, there we have it, folks. The solution to find subarrays. Hope you enjoyed, and see you in the next one.